Assalamu alaikum. Good morning, ladies and gentlemen. Myself, Sumaya Israt Moin, lecturer, Department of Mechatronics Engineering, Rashi University of Engineering and Technology. Along with me, we have Jalaluddin and Shapnil Shahakotha as moderators to provide any sort of technical support to this session. Today, we are in the second day of International Conference on Automation Control and Mechatronics for Industry 4.0. Current time is 10:30 a.m. Bangladesh Standard Time. I would like to welcome all of you in the invited session 1 of ACMI 2021. I am your host for this session. On this occasion, we feel honored to have Dr. Ripon Kumar Chakraborty from the University of New South Wales, Australia as an invited speaker. ACMI 2021 has got a new dimension to have a resourceful person like him. So dear audience, this is the time to welcome our honorable invited speaker, Dr. Ripon Kumar Chakraborty, with big round of applause.
Thank you so much.
Thank you.
Can I share my screen?
Sir, I have to introduce our session chair and co-chair, and they will permit. Okay, thank you, sir.
Sure.
Thank you everyone for your appreciation. It's our immense pleasure to have Professor Dr. Mohammad Mizanur Rahman from Chittagong University of Engineering and Technology as session chair, and Dr. Nahid Akhtar Jahan from Southeast University as a session co-chair of this invited session. After the end of the invited speaker presentation, there will be a question and answer session. All the audiences are requested to write question in the chat box if any. Audience can also raise hand in Zoom after the end of the presentation. Now, I would like to request our honorable chair and co-chair to take the floor and introduce our honorable invited speaker to the audience.
Thank you, Sumaya, for your nice introduction. Good morning, everybody, and welcome to the second day of ACMI 2021, organized by Department of Mechatronics Engineering, GREAT. Today, I would like to introduce my whole team for this session. I am Dr. Professor Dr. Mohammad Mizanur Rahman with you as a session chair, and I have my co-chair, Dr. Nishad Akhtar Jahan from SU, and we have our convener Sumaya Israt, lecturer of Mechatronics Engineering, GREAT, and we have moderator Jalaluddin and Shapnil Shahakotha. Welcome everybody and all the participants to today's session. Just a few talk regarding our today's speaker, Dr. Ripon Kumar Chakraborty. He's a distinguished researcher in this field. Today's topic: what digital technology-based extensions can trigger the developments towards supply chain risk analytics. So if I introduce Dr. Ripon Kumar Chakraborty with you, Dr. Ripon Kumar Chakraborty is a lecturer in system engineering and project management, and also a program coordinator of Masters of Decision Analytics and Master of Engineering Science at School of Engineering and Information Technology from UNSW, Canberra, Australia. He's currently the group leader of co-disciplinary optimization under capability context research team. He did his master's from UNSW, Canberra in 2017, a very young researcher and well-known researcher. And from our discussion, he's from Wei Xu. So welcome our Weiian. and he did his bachelor's and master's from Wei in 2009 and 2013 respectively. A very well renowned researcher from Canberra. His research interests covers a wide range of topics like operation research, project management, supply chain management, artificial intelligence, cyber physical systems, and information system management. And he published a lot of publications, for example, 2 books, chapters, and almost more than 85 technical journals, conference papers. His research program has been funded by many organizations such as Department of Defense, Commonwealth Government Australia. Actually, a lot of things to share with you regarding Dr. Ripan Kumar Chakraborty, but we will not expend our time here. We'll just waiting for the interesting topics, today's topics. And before that, I would like to request our today's session co-chair, Dr. Nishat Akhtar Jahan, to tell something about the session. Please, Dr. Nishat Akhtar Jahan.
Thank you, sir. Thank you for giving me the opportunity to say something. I would like to express my deepest thanks to each and everyone working behind organizing this wonderful event in this COVID-19 crisis. And it's undeniable that this kind of online platform really plays an important motivational role for all the researchers all over the world in this crisis, especially the organizing and committee chair, especially to you, Professor Dr. Mohammad Mijanur Rahman from Kuwait, and our moderator and our convener Sumaya Ishrat Moin, and moderator Jalaluddin and Swapnil Shah. And we really feel privileged that Dr. Rupan Kumar Chakraborty is here with us to deliver his speech. And we have already known about him. I would like to mention that I'm Dr. Nahid Akhtar Jahan. I finished my PhD in 2013 in the field of electronics for informatics from Laboratory of Nanophotonics under the Graduate School of Information Science and Technology, Hokkaido University. And thereafter, I got my postdoctoral research fellowship in the same laboratory. And I worked as an associate professor in East West University. Now I'm working as the chairperson of the department and associate professor in the Department of Tripoli in Southeast University. Thank you so much. You're welcome.
Thank you, Dr. Jahan. Now, welcome all the participants in our session. Now it's time to hear from Dr. Ripan Chakraborty. So please, Dr. Ripan Chakraborty.
Thank you. At first I should thank to Professor Mijanur Rahman and also Dr. Nahid Akhtar Jahan. So in my list, she is mentioned as Nahid Akhtar Jahan. So thank you for a very good introduction about me. And it is indeed a pleasure to have the opportunity to talk at front of you. And eventually what I have seen that both of you are were in Australia in a stage of your life, which is fantastic. So we can relate more. And time permitting, we can also talk about few other stuffs as well. But of course, thanks to Sumaya for giving me the floor as well, and all the other moderators, Swapnil and Jalal. So if you don't mind, I'm just gonna share my screen so that we can start. So can someone please confirm that you can hear and see the screen?
We can hear you.
Thank you, Dr. Jahan. So, yeah, thank you for the introduction. And I'm from, my name is Ripan Chakraborty, of course you have heard. So, and I'm also working as the Deputy Director in Capability Systems Center, which is really in Australia, in particular in the system engineering domain, a very well-known capability system center. We have yearly turnover around $3.5 million, mostly from defense research grants. And I'm basically all my research works and teachings is somehow related to decision application analytics and system engineering. But by background, of course, probably many of you know that I did my bachelor's and master's from BUET on industrial engineering, and then I did my PhD from UNSW, and my PhD was in computer science. Funny story to start with, like a few years before, like 3-4 years before, someone told me, okay, why, like I'm doing PhD on computer science, being having a background from industrial engineering, because still many people have their, the understanding, kind of a parochial understanding that industrial engineering is nothing but like there is no relation between computer science and industrial engineering. So all my discussion today is basically for them who still think that computer science, like still undecided how computer science can be related to industrial engineering. Okay, and like, of course, one can complement the other, and all my future slides which I'm going to present today is somehow you will see the application of different technologies, or rather computer-based technologies, to augment the business practice. So it is kind of a mixture of industrial engineering and also computer science, but many other disciplines, say electronics and electrical, people will also find something synergic during my presentation as well. And feel free to let me know, but like probably you can text me or wave your hand if you want to stop somewhere. Otherwise, as Sumaya mentioned and also Professor Mizan mentioned, after completing my session, definitely I'll take any questions which you may have. So, of course, as the term, the title itself explained, that I'm going to talk about the keywords. If I just talk about the keywords, it will be digital technology-based extensions. That is one important, I would say, phrase. And then also trigger is my second keyword here. And then the supply chain risk analytics. So supply chain is more about, of course, it is not really the concern of only industrial engineers, rather everybody whoever are somehow connected with the industries or business, right? Because a supply chain has multiple stakeholders, and a customer is a body of that supply chain as well. So everybody, whoever, like irrespective of their discipline, irrespective of their knowledge and expertise, everyone is a part of a supply chain. So sometimes we usually consider that that is somehow a conceptually a part of industrial engineering, but that is not 100% true. So as because the theme of this conference is also related to Industry 4.0, that is why I just brought this picture here, that why I am here and why I'm talking about supply chain when the theme is Industry 4.0. So probably you know that the smart supply chain here, the one I just marked here, is one of many building blocks of Industry 4.0. And I'll talk about later why I'm like, what is really smart supply chain. But all we know, from a smart TV to anything, whenever we say smart, it is more about how it is connected with internet or connected with advanced technologies, say IoT or cyber physical systems. So the whole theme, like how supply chain was before and now, how it has changed, the whole theme, the thinking, the perception among people, among practitioners, even the academics, how it has shifted is really a significant thing to know, because what uh, 10-15 years before, nobody would have considered the way they are thinking now. I would definitely thank to Industry 4.0, but definitely probably that Industry 5.0 is also knocked on our door, and it is already, people has already started working on Industry 5.0 as well. So the thing I'm trying to explain here is the typical challenges or the redefined challenges in this era, probably the post-pandemic era, is of course the business environments become more complex now, because we have enormous pressure. There are like chains lost. Most of our products are somehow the customization has increased a lot. We change our taste, we change our preference every day. So that is why the customization is a kind of a headache for any manufacturer and the whole supply chain, and volatility also. So that is like, these are the things which a manufacturer or anybody in a throughout the supply chain needs to interact or needs to think about. So that's why I'm saying this is a kind of a redefined challenges, although we had this kind of challenge before, but these things are getting more and more complex and tougher day by day. Increasing number of disruptions and far-reaching effects. Why I'm saying far-reaching? Because particularly after the pandemic and due to the emergence of technologies, so the disruption in at one tire at one end of a supply chain is the consequence is extremely higher than what it was before. Okay, and of course the technological advances, so most of our mathematics based concepts, techniques related to supply chains or the business or financial economics are now somehow old school, because mostly due to the technological advances. Of course, you know, that's cyber physical systems, then advanced manufacturing systems, but sensors, the advanced sensors, 3D printing, there are many to name, but all this somehow influence the decision makers, and that is why the previous way of dealing with or thinking the supply chain has drastically changed. Another one is, of course, it is somehow undeniable how COVID-19 has affected the whole supply chain, not only in the developing countries, rather in the developed countries too. So there are endless number of examples we can pick, starting from, say, for example, toilet tissue, for an example, right? So, and that is why somehow, fortunately or unfortunately, whoever are somehow researching in supply chain or practicing supply chain steps, they are getting a huge peak, and like they are seeing a very good future, at least for next few years, particularly the pandemic hit, because the whole supply chain is kind of getting a buzzword in this time. And the emergence of artificial intelligence, definitely this is another undeniable fact, that the artificial intelligence it is not only or solely related to robotics anymore. People have been applying this artificial intelligence in many disciplines, and supply chain is not uh, an exception here. So all these things are redefined challenges, and that's why, like in my presentation, what I'm going to talk about, or what I have been practicing, I've been doing, is also somehow a redefined supply chain. And that is why I started with saying the computer science, because we are applying many tools and techniques from computer science here, really. This is just one schematic view. So you see the reference, this is just from a very good reference, but what they try to explain is how industry 4.0 will become even more valuable after the pandemic. That was the main theme they tried to explain, and I just explained that one too, that the industry 4.0 will become more valuable now after the pandemic. So here you can see the cloud here. So if someone is a bit unaware of what really the supply chain is, or how I am scoping a supply chain here, so usually definitely people might have their own way of explaining supply chain, but how I'm trying to explain here is, it should have, say, for example, from supplier, transporter to manufacturer, then customer, and a typical supply chain may have distributor, cross dock, sorry, many other small third parties within. Okay, so but how the COVID-19 has affected, you can see the international politics is now, say, for example, the relation between Australia and China has drastically changed in the last 1 or 2 years. Okay, so and that also affecting the supply chain. The climate change, this is not completely related to COVID-19 though, but here you can see the lockdown, the border closure, social distancing. So all these things somehow affecting the decision making. Okay, and what they're doing is they're imposing uncertainties in different echelon of a supply chain, or different tiers or bodies. And all these all together, from a decision maker's perspective, what he or she is trying to do to find out a better strategy, or how to mitigate those uncertainties and disruptions. Okay, so you can understand, sitting, say, for example, a manufacturer, for many big industry, big manufacturing firms, probably a supplier is from, let's say, manufacturer is in China and supplier maybe in from India. So, and probably their customer is solely based on Australia. So it is not really that everybody is within the same country who is always the same politics and same policies. So it is also the cross-border communications, and that is why I said that the disruptions or anything bad happens have far-reaching consequence, because it is not really within a country anymore. And due to the COVID-19 and all these things, uh, the whole thing get exacerbated. So as because my topic is also not really the supply chain, rather supply chain risk and supply chain risk management. So SCRM stands for supply chain risk management. So this is just a book definition how we define supply chain risk, or rather a risk, and then how a supply chain risk management. So I'm not going to read it out, but the philosophy here, say for example, for supply chain risk is the likelihood or impact of unexpected uh, events. Those events could be macro events or micro events, might be a minuscule level or maybe a big events, okay, which may have adverse effect or influence on a supply chain. So that is usually we say supply chain risk, but rest assured that there are many ways people have been defining risk for the supply chains. And when we say supply chain risk management, it is more about identification, assessment, treatment, monitoring. So usually it has four uh, phases or four important steps for a supply chain risk management. But most of the people who are working on identifying risk first, and then how to treat them to mitigate the whole effect. That is what usually the supply chain risk management correspond to. So in my research, what I have been working on with a few of my PhD students, really our main focus have been on identification, and then not really treating, but rather giving some decision points how you can work out to minimize the consequence or effect. Okay, so our main concentration has been identifying the risk, because that is the most significant part, for a business maker or for a policy maker. If they have a better algorithm or better sense how and when there will be any uncertainty or there will be any risk events, if they can make a sense of it, definitely the whole process, the whole future process will be smoother. So that's why our research is more about identification, which I'm going to talk about in future as well. So when I'm talking about supply chain risk management, uh, I have already talked about the advances, technological advances, right? So of course, IoT, you all know, heard about IoT, and people have been working on, very few people have been working on Internet of Things and how that can be related with supply chain risk management. So the latest paper which came out probably from 2020 or end of 2019. So you can understand this is really a very new research direction, because usually what happened, whoever has got the expertise in IoT, usually they are from either electrical or computer science background, and they don't seem to have very good understanding on what really a business is doing, or probably the supply chain and all these things. So the lack of one discipline is somehow affecting the whole embedded research. So, and that is what we are trying to build up here, that we have got someone from computer science background, someone electrical, and someone from industrial engineering backgrounds, and we are trying to integrate or embed all together. And that is why and how we are claiming that this is something a very novel research domain. So my main motivation to pick this slide here is basically to let you know that the supply chain risk management, it can be dealt with within an IoT framework, and it even like once it is implemented, we can easily understand how better it will be, because we all know whenever it will be on an IoT framework, the real-time communication will be ensured, right? So what will happen, so if I just talk about the next slide, so you can understand it. Just imagine if there will be a day when a decision maker in their mobile phone, they got the notification that, okay, something is going on, a kind of a risk alert in their mobile phone. And then they go to the computer, open the computer, run their simulation and optimization model, and then they revisit the whole decisions for their future actions, and like take action accordingly. So imagine how beautiful it will be, right? How effective it will be. Because usually what happen in complex business, identifying risk itself is a very challenging part, and hardly, like it is not that much straightforward, and definitely it takes some time to flow the communication from one channel to another. But with the goodness of IoT or the digital twin, what we can see in near future, if not now, is that a project manager or a supply chain manager or whoever will be a decision maker, for example, will get the notification in his or her mobile phone that, okay, listen, something is going on in you in this area, probably say, for example, in Australia, in particular city. So, and then it will trigger the whole system. Okay, is there something which is not thought of before? So, and that is why I said that identifying a risk itself will not help unless they have a fantastic simulation and optimization modeling tool. And here you can see a good uh, breeze between typical computer science and then industrial engineering perspective. So once you have the optimization tool, it will help you to prone and then tweak the whole decisions which you have made before, and now you are trying to make another decision out of contingency as per the risk alerts you have received from your mobile phone, which is somehow by virtue of a IoT, of an IoT or a digital twin framework. So this is something we all understand that once all this thing will be implemented, good thing is it hasn't been implemented yet in a mass level. Very few industries are trying to implement that one, and same for the researcher as well. We are trying to bring the idea and we are implementing in a small dummy level, which I'm going to talk about in future in my next few slides. But it is something, a fantastic research domain, going to be a fantastic research domain in near future. Okay. The another part is, I said, a new look of supply chain risk management is data driven. So of course we all know about big data or the data analytics. So you see the trend or the changes in the words as well. So before we say data scientist, now the data analytics. Project management is not itself a project management as of now. So usually we say project analytics, decision making is now decision analytics. So all the things, the words are somehow changing because most of the things are somehow data driven now. We have a huge number of data, which we usually say big data, to deal with, and we means here actually the industries. And that is why, how about if we see a supply chain risk management plan or a setup or a framework within, like which will be completely a data driven one. Okay, so you can see here, there are few different layers for a data driven supply chain risk management or disruption handling techniques. So for example, it will have optimization. So the previous figure I showed to you has simulation and optimization in the single platform, but I have here further splitted that one. Say for example, optimization and simulation. So it will work, definitely one will take output. Say for example, simulation output will go to there, and then the same thing from optimization to simulation. There will be few iteration within them, and after then we will have the data analytics. But what, like if we split them and then try to explore each of their opportunities, then the whole decisions or the whole output will further be, I should say, augmented. And this is how the current research domain is standing, which is data driven supply chain risk management. You can see from there is the optimization, simulation, and data analytics. So data analytics here for them is nothing but, say for imagine a computer with a dashboard, and your optimization and simulation model is giving you some figures and values and all these things. Okay, let's imagine just a pie chart or kind of stuff in your Excel sheet. And the reason I have colored these ones, these are few parameters or decision points which are in this time people are thinking of having a framework of data-driven supply chain risk management. Okay, so these are somehow I have been trying to motivate the audience that why we need because my title for this special session talk is also related with how technological driven, like technology can trigger supply chain risk management. So our pathway, our means here in my research team here, I have got a good number of PhD students and a few research associates. We have been working all together. Uh, we, so our main focus regarding the supply chain risk management, this is what our pathway has been. As you can see here, some of us working on big data analytics, some of us working on blockchain, of course, a few building blocks of industry 4.0, which I have shown to you on my second slide, and Internet of Things. So these are the things we are covering in my research domain. I'm not someone from additive manufacturing domain, neither I have very good background on electrical systems. So that's why these are the things which are untouched yet. But who knows, if we have someone who has got fantastic skill, probably will try to embed that one in near future. So in my next few slides, I'll try to explain how we have ticked those boxes. But before that, as I said before, if you can remember, the challenges, redefined challenges in supply chain, or rather supply chain risk management, is emergence of artificial intelligence, right? So this is just based on a very recent survey from one of my PhD students last 2 months before. She found out, like she tried to find out how many papers have been considering, say for example, like she splitted the whole algorithms in 5 different parts and tried to find out their percentages correspondingly. And what she found out is that machine learning has already covered 35% of the literature on supply chain risk management. She used supply chain operational risk management, and that's why it is SCORM. So 35% of them are dealing with machine learning, like people are proposing machine learning approaches, 40% evolutionary computing, so genetic algorithm or swarm based optimization techniques, and very few are on computational creativity. And you can see fuzzy logics has got 14% and 10% probabilistic methods. So we all know about all these techniques, but from here one thing is very clear, that the recent trend of research. Let me tell you, her literature survey was solely based on last 2 to 3 years research, because she was trying to find out the trend. And what she found out is evolutionary computing and machine learning has been the mostly applied techniques to deal with supply chain risk management or operational risk management. And from that one, another PhD student with me, what he is doing, he is applying machine learning, not really machine learning, it is machine learning, but I would say deep learning approach to predict supply chain risk. If you remember, I said the first task of a supply chain risk management is really identifying or predicting, like detecting the risk events. So what we have been working on is proposing different deep learning approaches to predict supply chain risk. So this is how, like what we have done here is basically, say for example, he just splitted the whole deep learning model in 3 different layers. So first layers, he just used the data to do the data decomposition and all these things. And then the second layer, he applied different deep neural network and or like recurrent neural network. I'm going to talk about them later. And finally, he has applied different classifier to find out the risk events, if their event is a risky event or not. So this is just a flowchart of how we have done this work. Say for example, I'm talking about the deep learning approach which we have applied, deep learning approaches really to predict supply chain risk. So what we have done on that particular work was, we took a data set from machine learning repository. Okay, and then what we have done is, as I said, the pre-processing, he has done the pre-processing and then feature extraction. So when he when we have done the feature extraction, we have used different kinds of recurrent neural networks and one CNN model. After then, we use classification to identify, the features, because okay, I'll talk about a bit more when I'm going to talk about this individually, the motivation of having all these processes. And after having the applying multiple classification techniques or classifiers, we found out, based on the evaluation matrices, what our main focus was to find out if there will be a in time order or late order. So if I talk about the problem in this particular paper, so what we have tried to do here is basically, okay, let's imagine that something is coming. Let's imagine we are the manufacturer, and then we have got a supplier order to come, and due to the COVID-19, or irrespective of COVID-19, in this particular work we didn't consider COVID-19, but we considered that, okay, we are not 100% sure that our order will come on time or not. So our main purpose for this research was to identify, by using a deep learning approach, if my order will come timely or not, based on different anomalies and different scenario which we have. So for example, I didn't have those all the information here because I tried to make it crisp, but yeah, that was the main purpose, to identify or to detect the risk in these regards, if the order will be on time or not. Okay, so pre-processing, if you see, the first step for this work is, as I said, once we accumulate the data, then the pre-processing. So as because the supply chain information is not really a simple data, neither a time series data kind of step. So it has multiple features. Say, for example, here you can see the format. It may have text, it may have data, number. So as because it is amalgamation of many different features, so definitely we need to do a pre-processing to identify the feature first, and then we need to do the feature extraction. And that is why we have applied at least 3 different feature extraction deep learning models. And then after then we keep doing pruning the thing by using classifier to get the final result done. But yeah, this was the main motivation of having the pre-processing, because the supply chain information is somehow not single data. So as I said, for a feature extraction in that particular work, what we have done, we proposed a by LSTM network, but I don't want to bore the audience talking about these models. This is somehow out of scope of this conversation, but what I'm trying to establish here that, say for example, with the application of this by LSTM network and then a deep by LSTM network, when I'm saying deep by LSTM, probably many of you can understand. Say for example, here we just applied one long short-term memory, bidirectional long short-term memory here, the first model. And in the second model, what we have done here is we applied the same thing twice with 2 different dropout layers, basically. And that is why we said it's a deep LSTM network, because we try to, enhance the performance of the first one to prevent overfitting. Basically, dropout layer is to use to prevent overfitting. Probably we all know that. So these are the schematic framework of our deep learning model. And finally, what we have done is, like I said, we have 3 different deep learning models here in the feature extraction stage. The third one was one-dimensional convolutional neural network. So, and you can see here, at last, what our main target was to identify if the order was delivered on time or not, right? So you can see the blue and red boxes. So by having these 3 feature extractions, and then of course the 6 classifiers, what we understood, or what we got from the results, this is just a reflection of our results, that of course, our model could identify the supply chain risk pretty convincingly. And out of them, you can see here, so for example, this one, which is SVM, the classifier was SVM, support vector machine. And when we applied the one-dimensional CNN, we have got 100% accuracy of identifying supply chain risk. You can see from all these things, the blue one here, and which is more clear in the heat map or confusion matrix here. So you can see for the one-dimensional CNN model, convolutional method, with when we applied, as I said, we had 6 classifiers, but when we applied the SVM, the percentage of identifying late orders and on-time orders if we just sum these two blue ones, two blue percentages, you can say it is 100%. That means you can imagine how accurate our model was. Among the three deep learnings, one has got 100%, another one 92%, another one got 94%. So this is one of our research which are one domain or one area of our research when we are trying to implement different deep learning models to detect supply chain risk. So this is another pretty much similar kind of stuff, but in this work we considered the COVID-19 restrictions or the the disruptions or the influence of COVID-19. And here also we try to identify if the shipment, say for example a shipment is coming from China to Australia, so a decision maker is not sure if the shipment will come on time or not, but he has got few data and anomalies and all the scenarios. So in this model we again propose deep learning model to identify if the shipment will be exported on time or not. Okay. And here also we try to propose different deep learning models. Here we came up with few new ones also. So JRU is not new, but we try to hybridize. We implemented TCN here, the temporary convolutional network. And here also you can see our model got 100% accuracy, particularly when we applied the TCN deep learning. TCN stands for, as I say, temporary convolutional network with a random forest classifier. In this particular instance, we saw that our model, our deep learning model, uh, could achieve 100% accuracy in sensing the supply chain risk. So this is like this is how we have been applying multiple approaches, and this research is still ongoing, and we are trying to come up with new and new problems and new machine learning deep learning models to identify supply chain risks. The second layer of the supply chain risk or identifying supply chain risk is really explainable artificial intelligence. So what happened, we all know that usually the machine learning models or even optimization techniques, evolutionary algorithms, they are somehow black box because they give result, but they don't explain why I have got those kind of results, right? And that is why the explanatory artificial intelligence has come out in 2019, end of 2019 or around. Uh, the initial bit of discussion came in 2016-17, but somehow in this time, 2020, 2021, this research domain is it has been getting some peak now. Okay, so explanatory AI is not really a black box anymore. So it can explain, say, for example, once the decision maker know, okay, I have got risk events here. So a machine learning or deep learning model, which I've just shown to you, can tell you, okay, I'm 100% confirmed that you will get some risk. Fantastic. It is identifying the thing perfectly, but it is not telling us why you are saying that there is a risk. What are the parameters involving and how one can affect the other? So that is why, and that's why I said deep learning and all these are black box, right? So we are trying to bring some glass box here, not black box. And this is just one quick pictorial view of the shortcomings of different algorithms. If you remember, I told you that there are many different, like if we can split the algorithms or techniques, artificial intelligence techniques, in 5 different layers: say evolutionary computing, machine learning, probabilistic, computational, and fuzzy logic. You can see here, we just try to explain uh, the shortcomings of them. Of course, they have some merit for sure, and that is why almost 95% researchers are working in those domain, but they do have some shortcomings too. And in this particular work, what we are trying to do, we just explained that, okay, irrespective of whatever the algorithm you are saying, they do have these limitations, which are, as I said, they do not capture the interdependence among features. Okay, so if you remember, I talked about features when I talked about deep learning plus supply chain risk management. So it is giving me the value, but not talking about the interdependence. They do not consider the impact which an external factor may have on influencing the risk given. They are unable to show the output explaining the interpretability of the model. So these are the 3 strong limitations of any existing machine learning models other than explainable artificial intelligence model, which usually we say XI. And the two common mostly used ones so far is local interpretable model agnostic explanation, which is LIME, and then SHAPE. So these are two common approaches so far. As I said, LIME came in around 2017 and SHAPE after that, but still this research is completely green in supply chain domain and many other domain too. Nobody have applied this kind of concepts in supply chain project scheduling of this domain.
Sorry for
Yeah, sorry,
interrupting,
Professor.
Dr. Ripon. Sorry
Yep.
for interrupting you. Actually, we are
Yes.
running out of time. We have another
Yep.
parallel session from 11:30. So please conclude within 3 minutes.
Sure,
And
sure.
yes,
I was actually wondering if I am going out of time. Thank you, Professor. Sure,
thank you. Thank you
sure.
very much.
Thank you. So the next part here is basically, as we said, automated explainable artificial intelligence. For this particular work, what we are trying to do here is we are not only considering explainable artificial intelligence, rather we are bringing some automation between them. So we are just having 5 different modules, okay, and try to explain the, like once the supply chain model, like once the model will identify risk, it will explain those things in a clear way, and it will have communication within itself. Okay, our aim is to bring multiple ACMI model and then have implement their automation or adaptiveness within. So I'm not going to talk about this because I'm running out of time, but as you can understand, this is another clearly a very good research domain which people haven't done yet. We have just started and we haven't got the result, but definitely this is something interesting story to talk about. The third, another story or another domain, as I mentioned before, is applying blockchain techniques in supply chain risk management. Again, this is a very new research topic, and very few research have been like progress. Probably the first one came in 2020 around. And what we are trying to do is applying blockchains in supply chains. There are plenty works when people said that we need blockchain and this is how we can implement, but nobody has implemented that one convincingly. So what we are doing here is we have implemented blockchain techniques, blockchain technology in a complex supply chain framework. You can see we had multiple tiers, and what we have got here from that particular work is we can convincingly show to the panel, show to the people in that research work that if you have a blockchain techniques, you can minimize the supply chain risk, or if I name it differently, bullwhip effect convincingly. You can see the blue ones. The scenario 2 is with applying the blockchain, and as you can see, it becomes almost zero. Once you identify the risk and take the measures. So that's all for these are so. Please remember what I have said here is basically I try to explain the few interesting research domain which are completely related to technology and how they can influence decision making in supply chain risk management. And a future extension of this can be, of course, applying embedding supply chains into project scheduling framework to think about a complete picture. So this is something which we are heading towards now, and I'm working on that one too. So that's all about my brief presentation. And if you have any question or any concern, please feel free to drop an email to my inbox. I'm happy to discuss any regard. Thank you again. Thanks, Professor Mijan. And yep, floor is yours.
Yeah, thank you. Thank you very much for your nice presentation. Now, Sumaya, maybe we can ask if any questions from the participants or any discussion from the participants.
Thank you, sir. The floor is open for the audience for question answer session. You can ask to our invited speaker if you have any questions.
Madam, I have a question. This is Mohammad Rasul Sarkar from IP department, Ruet, assistant professor. Actually, Ripon sir was direct teacher of me. So I have a question, sir. Did your model applies for all situations like during this pandemic situation, or like in our country, or in any situations did your model applies?
Yeah, thank you, Russell. Nice to see you here. Of course, it like as I said, one belt of our research domain is somehow applying techniques which are taking like different COVID-19 effects. And we have multiple people working on that, not only supply chain management or supply chain risk management, but also, COVID-19 has affected in many ways, starting from people's perception. So we are even a few of us working on vaccine distribution network, developing vaccine distribution network. But to answer your question, definitely we have considered different effects and consequences of COVID-19 in our model, of course.
So did you develop any algorithm or software for
So
algorithm like that?
yeah, so okay. If you are talking about only the supply chain risk management, yes, we have developed multiple deep learning models or algorithms who is now connected with a computer. If you just give me some information, it can automatically tell you the whole scenario. So yes, we have already got a fantastic, a few excellent deep learning models which are considering those kind of COVID-19 effect, particularly in supply chain risk management. But as I said, we are also working on typical industrial engineering aspects, like logistics and network design by considering some COVID-19 effects. And there also we have got multiple models ready to be sold.
Thank you, sir.
Sorry. Not a problem, Russell. Thank you.
Thank you, Honorable Invited Speaker, for your nice and informative session. With the permission of the session chair, sir, can we proceed?
Yeah, sure. I think no more questions from the audience. So please proceed for the next formalities.
Okay, thank you, sir. At this stage, our organizing chair, Dr. Sajal Kumar Dash, will share a certificate as a token of appreciation to our invited speaker, Dr. Ripan Kumar Chakraborty, and I would like to request our invited speaker to receive it digitally.
Dr. Ripan Kumar Chakraborty, thank you for being with us. You have been a true collaborator for us, and the Department of Mechatronics Engineering is really being benefited for you. As a organizing chair of this conference, I would like to take this opportunity to share this certificate of appreciation to our invited speaker, Dr. Ripan Kumar Chakraborty. Please accept it digitally.
Thank you, Shazal. Thank you, Dr. Shazal. And it is my pleasure. And again, as I said, thank you, everyone, whoever was involved. Thank you for the certificate. I'm definitely happy to have this.
Ladies and gentlemen, it is time to appreciate our honorable session chair and co-chair. I would like to request our organizing chair, Dr. Sajal Kumar Dash, to share the session chair and co-chair certificate to our respected session chair and co-chair as a token of appreciation.
I'm honored to hand over this certificate to Honorable Professor Dr. Mohammad Mizanur Rahman sir. Mizanur Rahman sir is truly an advisor for us. He has been with the conference ACMI 2021 from the starting of the conference. We received many suggestions from him, and yeah, it's a pleasure for me to share this stage with him. So, Professor Dr. Mohammad Mizanur Rahman, I would like to hand over this certificate of appreciation as a session chair for this invited session, and would like to request you to receive this certificate as a token of appreciation.
Thanks, Dr. Sajal. I'm very delighted to have this, and I am very grateful to the ACMI Organizing Committee 2021. It's a very interesting session, and the whole program, I was from beginning inaugural session, very nice and organized session, I would say. Thank you very much. Thanks.
Thank you, Honorable Session Chair. Now I would like to request our session co-chair to receive the certificate as a token of appreciation.
It is my pleasure to hand over this session co-chair certificate to Dr. Nahid Akhtar Jahan. So I came to know that she became ill yesterday and she went to hospital also. So I was actually knowing about her that whether she is good or not, because I came to know that after completing her session co-chairing yesterday, she had to went to hospital. So Dr. Jahan, are you okay now?
Yes, I come back in the morning, and anyway, I'm doing fine now. Thank you for this e-token appreciation. I highly appreciate, and it was a wonderful event, and it was a wonderful presentation from Dr. Ripon Chakraborty. It is my privilege to be part of this. Thank you so much.
Thank you, Honorable Session Co-Chair. Ladies and gentlemen, it's time to capture this beautiful memory as a source of inspiration for next edition of the conference. I would like to request all of you to open your camera to complete this photo session. I would like to request all of you to open your camera for a photo session. Thank you, everyone. For your kind information, 6 of our parallel technical sessions will start from 11:30 a.m. and you are cordially invited to join those sessions. Thanks all for your participation in this session and make this session live. With the permission of the session chair and co-chair, I would like to close this session.
Sumaya, just a minute. I would like
Sir.
to, I know the time is very fast running and we have another session. So in short, I would like to thank our speaker, Dr. Ripon Chakraborty, and all the participants today's session, and especially the organizing chair, Dr. Sajal Kedash, and the organizing committee, the organizer of this conference, Department of Mechanical Engineering Grade, and all the faculty members, and today's team members, you, Sumaya Israt Moin, and our moderator, I guess, Jalaluddin and Shopnil Shahakota. Thanks all of you for your time and enjoying the session. Thank you very much. Thank you.
Thank you, sir. Thank you very
Thank
much.
you, sir.
Thank you very much. Thank you.
Thank you.
Assalamu alaikum, sir.
Bye.